Okay, it's live now.
Yeah. Hey guys, welcome to our hangout for compiler theory and practice class. And both of our TAs, Chao and Yu Hong, and myself are here. So hope you're pacing well, and we are almost getting to the end of the semester. Um, so some announcements to begin with, and then I will clarify one question that had come up about the project. So first of all, our finals will be held through the Proctor track, and um, those who are new to Proctor track, who have never done anything in Proctor track, will have to be onboarded. So we have given you a roster to David Joyner, and they should have set up your accounts. You should have gotten an email from Proctor track about your account, and so please log in using your current password. Set up your account. The setup download some software from Proctor track and checks your computer for the webcam, for the amount of memory and all kinds of resources it needs, because it records the video during the time when you take an exam, and it needs a lot of storage there. So this process is called as onboarding. So checking your platform is correct and your account is set up right and software is installed properly and so on. And once you do that, you will get a small test there inside your account, which will just check if everything is going okay. It's not a test from um, our subject. It's a small test, to just general test to see if Proctor track is working well on your machine. So do that, and once you're through that, uh, Proctor track knows that you're all set up. So please get all this done ahead of time within this coming week, so that you're all set. Some of you might have had Proctor track in some earlier time, but may not have used it for some times. They do occasionally have upgrades. So it is a good idea to log in into your account, make sure your software is up to date, and so on. And also, as I mentioned, Proctor track needs a lot of storage on your machine. So please delete some unnecessary files, because otherwise, sometimes what happens is when you take the exam, the Proctor track crashes. So now about the exams, logistics. We will be doing the exam as per the pacing schedule. So it will be open during that interval. We'll just talk about little logistic issues right now. And then next time we'll talk a little bit in more details about the format and so on. So the exam is going to be comprehensive. It will have two types of questions. One is essay type question, about 5 to 6 of those. What you will do is you will get a scratch piece of paper. We'll work out the solutions of the questions that are asked, and then you will transfer the answers onto Proctor track, provide a text window in the format which we have asked you to, and that way that will take care of the essay type questions. About 6 of them you can expect, and then about 12 of them you can expect in terms of multiple choice. It could be single multiple choice or multiple correct answers that will be specified to you. And the total duration, as I mentioned, is 3 hours and 15 minutes. But the real duration itself is 2 hours and 45 minutes. So we are adding a half an hour just in case you run into any issues during exam, like machine freezing or crashing, or the Proctor track hanging and so on. So if any of these kind of things happen, please contact the Proctor track support. They have a live support when the exam is being given, and they will work with you and take care of you right then and there. Most of the time, your work will be saved and it will be available, and you will restart the exam from where you left, and they can help you with all that. Sometimes, very rare occasion, it is lost, in which case we'll allow you to retake the exam and then you can work with us. If it's during the pacing window, then they can set you up to retake it, and anytime again in that particular window. If you want to do it outside because of whatever reasons, then you got to let us know, and we will help you get set up there. These are very, very rare occurrences, but we need to get set up ahead of time and make sure everything is okay. So please do that next week once you get the emails about your new accounts. Um, Again, in terms of now the project and homeworks, hope you are pacing well. And it's a good idea. The homework is very simple. So get it done and get it off your plate, and then focus on the project and finish it at the deadline. Um, the TAs tell me that most of you are doing very well in the class. That's great news. And if you have any conceptual difficulties or any such things, please let us know. And before the exam, the format of the exam will be very similar to the homeworks in terms of essay type questions. And so going over your other homeworks and doing some similar problems from the book, reading things from the book. Please don't just rely on the videos. That will not really help you. You have to read the book, and preparing accordingly, reading the topics, solving some similar problems will help you prepare and for the finals. Now, let's turn to the one question that we had about the project. So this is more about implementation strategy. So the question was, how do you implement these variables in MIPS or temporaries in MIPS on the stack? So here is the way we envision you doing it. So first of all, you have the IR in symbolic form. Then the next thing that you do is you run a register allocation pass over it and figure out which temporaries and variables get registers. And those who get registers, their names are replaced by the register names in the IR. So the remaining ones are the ones which do not get registers and have to be given a memory location. So now the remaining ones, what you do is you allocate them in the data segment. You make a small internal structure and you do a data layout of this variable and that temporary getting such and such sort of location in the stack. So typically this is some kind of an offset, and this is a base. So as per the MIPS, you will allocate all these temporaries and variables which do not get registers into the data segment of the MIPS assembly and assign them some offsets and so on, and replace their, again, references in the IR by their offsets. So now we have the IR completely in terms of either register names or in terms of the offsets for these variables which do not get registers. And from there, you simply drive the assembly code generator, and it will, whenever it wants to reference a particular variable in the code, it will first check if it is in a register. It will use the register name if it is. If not, it will use it will generate a load for it, get the value from the stack or the data segment using its offset, and hold it in a temporary register, and then operate on it, generate the new value, and so on. So that is the way the whole code generator will work in sync with the IR, which will have attributes either as register names, those which are getting registers, or the ones which will be offsets in the data segment. So those two passes should precede code generation pass. And again, those which do not get registers, you'll have to generate the loads for getting them into temporary registers and then operate and so on. And then, of course, once the new value is generated, again, if it does not have a register associated with it, you'd have to store it. Again, you look up its attribute if it is an offset, and then you store it at that particular location, generating a store. So that's a very clean and neat design, and that's what is pursued in practice. So in other words, the IR gets decorated with the replacing the symbolic names with the register names, or the offsets, and then from there the code generator takes over and is able to generate the code. This kind of a design allows you to keep the code generator completely independent of the register allocator, which should be the case. All right, that's sort of what I have, all I have. And if you face any problems, please do not hesitate to use Piazza, and we'll discuss it in case it needs more attention. We'll try to answer it over there first. And let's get this last bit of project done and then prepare for the finals. And I would like to ask if Chao and Yuhong have anything further to add, or any comments or any things that they would like to say.
I prepared some example IRs for this project phase 2 backend. I'll release it later after this office hour.
I have created a test exam.
Oh, okay.
Hello?
Yep.
I mean, I have created a test exam on the prototype track. So if you log into your account, you should see it. So if you cannot see it, it seems like could be some problem with your account. Just so please let me know. I think if everything goes well, everybody should have an account on the prototype track right now. We have 6 new testers. So just try to log into your prototype track account with your GT username and a password to check whether everything is okay or not.
All right, great. Thank you, guys. And have we posted the actual test cases and all for the project, and to really test the final generated code and all that?
Sorry, I didn't hear it.
Yeah, so I was wondering if we posted some test cases for them to check if the final code is working right or not.
Yeah, I will do that. I'll do that.
Yeah, please go ahead and do that. That way, I think they should be now getting ready to generate the final code. And again, we want to make sure that we cannot give any extensions. So please stay on track and get this week, and next week is the last sort of week for us to finish this off. So coming week is the last week. So that's why I think these test cases will be important for them to get rid of any bugs or any problems. And so go ahead and do that, Yuhong,
Okay.
as soon as you can. Yeah.
Okay, sure.
So apart from this, are there any other questions or anything else we should be discussing?
This is Robin. So I have one quick question about the exam, or maybe you're going to cover it next week. Is it open book, open note?
No, it is closed book, closed notes. It's everything closed in terms of resources, internet or book or notes. So let us study offline and then work on it.
Okay, good to know. Then I had another question. Just I was interested in knowing. So when you're doing the webs, the def use webs, and so say you have one, so they can kind of overlap because you could define it outside a loop, use it inside a loop, redefine it in the loop, and then the loop comes back and uses that same use again. So they're not completely independent. So I read something about then you should merge those.
Yes. So so the definition of webs is just like this, that in the static sense, if any use is reached by a definition and is reached by another definition, all three of these, the two definitions and the use, should be all a part of the same web. Because what can happen here is the registers, if they're different for those two definitions, then which one participates in that use is not very clear. So that's the motivation behind the webs. And so if you have, for example, a definition sitting inside even a a loop which is feeding to a use, and that use is also fed from outside by another definition. All three of them should be in the same web.
Okay. Yeah, that's what I figured, but it just wasn't completely obvious. So, because otherwise, like you said, if they end up in different registers, then you get the wrong answer.
Exactly. You cannot really have two different register names, and that's why all this is one unit. So what is a right unit which feeds the right values to all the users? That's the whole point behind. So it's really, in formal terms, it's a DU set and UD chains closure. So if you go from a definition to all its uses, and from there bounce off to the corresponding other definitions, and keep doing this activity, when you don't find any more things to add, you terminate. So that's the algorithm to generate a web.
Okay.
Does that make sense?
Oh yeah, it makes sense. I just thought it was interesting. And then I had another question as I was implementing things and thinking about whether we had assignment statements at the top or not of the IR. The idea of these SSA languages came up, which I forget what it means. Single something assignment.
Static single assignment.
Static single assignment.
Yeah, SSA stands for static single assignment. And I think one of the book chapters about the IR should have a small description of SSA. So the main reason for SSA is, of course, doing lots of optimizations, which we haven't really touched upon in this class. But go ahead with your question.
Yeah. So my question, I already made a decision, but when we have our Tiger, and if you initialize a variable at the top in initialization, then its def use chain starts all the way at the top of the function. And so its web is really big. So if you don't define it at the beginning, but before you use it closer, then its web is really smaller. And then I was trying to decide how I was going to use that. And then I was reading about these SSA languages. So I was just trying to think of how those interacted with each other. I don't know that Tiger is SSA.
So SSA is really an IR. So what you do is you typically generate the way you do in the current project, which is giving the temporaries in terms of quads and all that. And then you have a separate pass following that, which converts the IR into the SSA form. So the SSA is the IR level concept, not at the source level.
Oh, okay.
Yeah, so it converts this into another IR, which is at the which is a static single assignment by inserting fee functions and renaming variables and so on. And that prepares the IR for pretty advanced optimizations, especially related to extension of what we see in terms of local value numbering or global value numbering is the optimization, what it is called. And it facilitates many optimizations and rearrangement of the IR. Then the IR is converted back into a non-SSA form, which looks similar to what you guys are doing in your project. And then finally, that is converted back into register allocation and all that. So in between, there is this particular step. It's used by advanced compilers. All the production compilers use that. If you want to take a look at it sometime after the class is over, the LLVM is a great example of an IR, which is SSA based. It's also used in production because it's backed by Apple. It's used pretty much by all the production compiler houses these days. So that's the reason why SSA is used mainly. Since we did not really cover much of optimization, and it would have been a huge amount of additional work, we are not really looking at that. But yeah, it is useful for mainly machine-independent optimizations, actually.
Oh, okay, great. Thanks for that answer.
Great. Thanks to have you on board, Robin, here.
Hello, Professor. This is Paul.
Oh, hey, Paul. How are you doing?
I'm okay. So I've just this week I completed the Briggs color register allocation and also the intra-block allocation. My colleague is working on the naive register allocation. My question is concerning the, let's just call how the IR will look after you have actually allocated the registers to the variables. So I'm able to actually allocate variables to registers, but I was wondering about the instructions. Do all the instructions have to be either a load and store? Because in my intra block and even in my Briggs allocation, I'm getting still instructions such as return, call R, assign. Should those instructions be left intact, or they should be all converted to a load or store instruction?
No. So here's the thing. So as I was mentioning, I guess you join in between maybe after I explained the IR in terms of its register allocation. So keep the two phases, first of all, code generation and register allocation, independent of each other. The way things work is you start with the IR, you do register allocation on it, and some will get registers and some will not get registers. So those which will get registers, if the definition is already synthesized into the register, which will be the case, they will stay in the register. And at the end of their live range, because these are all purely local variables of function in our case, they don't need to be persistent. So you don't need to store them back on the stack.
Okay.
So those which have gotten registers throughout will simply be evaluated by the instructions in registers and will not be persistent. But those who do not get registers, now you will have to actually find out storage for them in the data segment of the code. Use the MIPS for deciding the location of the variable, and note its offset. And then using the offset, decide where to load it from. So you'll have to generate a load instruction for them, because their value, persistent value, will be found only in the memory. So those will need a load, and if a new value is generated for them, we'll also need a store, because they are not going to find a register. So the ones they are evaluated, so where they will get evaluated will be a scratchpad register. Okay, and then you will really just store them into the corresponding locations. So once you do this register allocation, depending on, so if in case of naive register allocation, you will get everything loaded from the memory. Okay. And if there is no modification, you don't have to have a store. If there is a modification of value, you have to have a store. Okay. In naive case, in case of intra-block, again, similar things. And as I mentioned just now about how to deal with the global register allocation, some will get registers, they will completely stay in register. They will not get a memory location, because they don't need to be persistent. Now, in case of other languages which have global variables and which need to have persistent variables which escape the analysis unit, which are pointers and all kinds of return values and so on. So you have to write them back into the stack locations. If they're getting a stack location, or they are getting a global location, they have to be written back there, or they have to be written back in this heap location, whatever is the case. And so this whole thing then changes in terms of identifying what variables need to be persistent, and you need to write them back. Even though they might have gotten a register, because they may have uses outside the current analysis unit, like a function call. They may have use, if it's a global variable, for example, they will have use outside the current function call, and that's the reason they need to be written back.
Okay.
That makes sense to you?
Yes.
So I would start with simple code generation and get it to work with naive. From there, I would relax it in the sense somebody gets a register, you simply don't give a persistent memory location to that variable and simply keep evaluating in the register.
So basically, your approach is to create actually a simple code generator with maybe the let's just say the register location that we've done already, for maybe to just see how to translate those register locations to MIPS, just a simple way of doing that, and then of that, then now you actually perform more complex operations on the MIPS generator.
Right. So, I mean, the main thing here is if you can get the naive code generator to work very simply, because you are actually doing the loads from memory locations. So you'll have to give memory locations to every value register, every variable. Okay, and you'll have to do loads on them. And if you can get it to work that way, then when you have register allocation done, all you need to do is not worry about getting um, a register for that variable, or not giving a memory location for it, and simply trying to change the attribute of that variable to a register. Okay, so the way the code generators typically work is like this. They will traverse the code and they will find out, what do I do about this value A? Is it given a register? If it is given a register, then I'm going to use the register name for that value. So that is as simple as that. Okay. If it is not given a register, then I first do a load on that value. So now where do I do this load from? I need to find out its memory location. So I consult the attribution of stack. What is the stack offset? And I will do a load from there, and I will get it into a register first, a scratch pad, and then I will proceed with the operation like addition and all. Okay.
Okay.
So that's the way. So keep that in mind, that that's the way the code generator is going to operate, and design it that way. And then it's a matter of simply plugging in the right attributions.
Okay.
So if you don't have register allocation, for example, nobody is getting a register. And
Yes.
so the code generator will simply work off memory locations, will generate the loads, will get the value in Scratchpad, will operate on it. And if the value is modified, then it will generate a store as well.
Okay.
However, if it gets a register, then it will simply use the value, the register name, and it doesn't have to generate a load nor a store. Okay.
Okay.
All right.
Makes sense.
Great.
Then my other question is concerning whether we have working MIPS code. So, for example, maybe at the end of the MIPS generation, you get maybe some file.s, and when you run it, it doesn't give perhaps a correct answer. So, are we going to be penalized for that, or?
You should generate correct code, right? You should debug this, why it is not doing it.
Okay, it's just to know about maybe how you're going to assess that.
Right, because correctness is really, really important in compilers. So we will definitely be weighing pretty heavily on that.
Okay.
Because if you're not able to generate, so there are several levels here. The code crashes, doesn't work properly at all. That's probably one of the lowest levels. Then the code runs but produces wrong answers. That's another one. In between could be the code doesn't terminate, or things hang, and there will be penalties at different levels. Yeah, so you should definitely debug using simple small Tiger programs, and make sure the generated assembly is correct. And if it is failing to give the right answer, or giving any other kind of errors, definitely debug your compiler phases, what is going on.
Okay.
I think the IR should be fine. From there, maybe the registers are given in a wrong way. Maybe the code generator is overwriting some values. Something is going wrong. So it's best to debug all this with small test cases. And you can write your own small Tiger programs for this.
Okay.
Okay.
All right.
Great. And I guess I have instructed you Hong to also put in some test cases. That way you will get some additional help. And you can publish your test cases on Piazza. We encourage all the groups to publish their test cases. That way we'll have a nice pool of test cases.
Oh yeah, it's a good idea.
Right.
Oh, that's good to know. Thanks.
Yeah. Thank you.
Then it will also be good to have a sample register allocation IR, like so just to keep us on track on whether to know whether we're doing it correctly or not. For example, when you do the intra-block allocation and you get the respective allocation of registers, perhaps it would be a good idea to just compare and see whether what you've generated and maybe what the samples that you're going to share actually are similar or you're in the right track.
That's right. So also, again, it goes back to small test cases. So you guys have all now learned that there is a simplest possible thing is maybe just a few instructions in a basic block. So that way you will really see that you are executing very small set of maybe just the arithmetic instruction. No control flow, for example, just a set of few arithmetic instructions, and you will see its IR, you will see its expected behavior, that is executes top down, and then make sure that works with an IO and intra block, and then slowly complicate it. Then you can just do something which has an extended basic block. So something like a few statements followed by an if then else condition, but no loop still, and test that out. Then you can go for a little bit something with a simple loop. Then you can keep making things more and more complex. So that is the way I would generate test cases, so that you yourself also know what is sort of the expected answer there, how the IR should look, how the registers when allocated should look, and so on. Because the debugging, the compiler development is a little bit tricky. I mean, we don't have proper tools there because every IR is different, to check if these registers have happened correctly or not. It's just a matter of you running and checking and making sure that something is gone wrong here. Maybe the register names are not right, or maybe they have mangled. Maybe some register is given out in a wrong way. Maybe there is a coloring pass which has a problem. So I would really work through this in some very small test cases.
Okay. Thank you, Professor.
Sure.
I think I also noticed that sometimes how well, particularly the block, the intra-block one works, kind of depends on what's in your block.
Absolutely.
So if your blocks are really short with only a couple of variables, there doesn't seem to be a big win there sometimes.
Yeah. So the live range should exhibit maybe some sort of pattern, maybe different cases that one live range has ended and second has started. So you should obviously see that maybe the register was given out from one live range to other, the other ones which have lots of overlaps. And you can play and move around these statements. You can replicate them in a linear code. And some variables are sort of done in terms of their live range. Some may be live across. And that's why maybe you need to insert a store at the end of the block. So these kinds of small test cases which should allow you to focus on, what are the different decision points. If you check each decision point, and make sure it's correct. Then hopefully the whole thing works together as a unit. Because
Hopefully.
the combinations of these could kind of become a little difficult to debug. So I think the debugging would be a good idea to focus on what are the decision points that, for example, this particular range is ending here. And so there's no need to put a store there, but there is a need to put a store because there could be potential use outside the basic block. And testing each one of these things, I guess, hopefully if you cover all these different angles, then things could probably go well.
Okay.
And then once you get past some of these simple ones, then you definitely can, actually you can auto-generate it in the sense, take the same Tiger program and replicate or move around some statements. And you could use your parser actually for that, but you could easily do it just manually too. Shouldn't take too long. And Yuhong will be posting some test cases as well.
Yeah, I'll do it like yeah, right after this, officer. I have already packed it up.
Mm-hmm. You can generate maybe some of these test cases in an automatic way, especially the complex ones.
Yep.
Interestingly, we have compiler testing research, which so the compilers do have bugs. It's a little scary to know that because they're like any other software. They're very rare. Most of them are confined to really extreme corner cases. So we do have some research on generating all kinds of these test cases, harnesses to stress out different parts of the compiler. But that probably is a topic for some other day. There's a work going on in our lab and others in terms of how to stress out maybe the... So parsers rarely have errors, but semantic analysis onwards, because these are manually written phases, they get in trouble because they could have bugs. And a lot of bugs could exist even, especially when the language has exceptional semantics, because some optimizations do not, they move the code around and they do not really gel well, so to say, with all kinds of exceptional behaviors of the program. So obviously you cannot turn them off because otherwise the code will become horrendously slow. But you have to make sure that it doesn't get in trouble under certain exceptional behaviors. So there's a lot of testing done on those parts. And maybe if somebody has interest, we can talk sometime about it. So Robin and Paul, you guys have progressed well in the project so far. How much work is remaining?
Well, I got the factorial recursive one running last night, so I'm very happy.
Oh, good.
I'm looking forward to the test cases to see how that goes. Could be a lot of fun.
Cool. But you pretty much finished the implementation, looks like, is it?
Yes, I've done all three of the allocations, and I have tests for the basic categories like arithmetic, if loops, for loops, function calls, several other things.
Great.
Yeah, but there's a lot of code and a lot of opportunities for bugs.
That's always the case. How much is the code base right now for you?
I counted this morning, I had 7,500 lines, but that includes all the dead code and all the comments and all the blank lines. And that's the front end and the back end.
Okay.
So, and there's a lot of repetitive code. If I had to do it again, it would be simpler.
Does it include the includes the auto-generated code from the Antler? How much of it's Antler generated, and how much?
That doesn't include the Antler code. The
Oh,
Antler
okay.
code is another few thousand. And I used, if it's okay to share, I used Antler both for the IR and for the Tiger step. So
Sure.
that's how it seemed once we learned how to do that, it seemed like the obvious thing to do.
Yeah, that's correct. Oh, wow. So this is 7,500 lines of code without the antler parts. That's becoming pretty significant code base. I think that is what we had, yes, for the project so far. That's on. It seems in line with whatever we had, but we don't know what to cut from here. Any suggestions? Or is it a little too...
I would cut floats.
I see. But then we have only one type.
Right. Now, I think we need floats for the first part. I'm not sure we need floats for the second part.
Yeah.
Just because the focus is more on
Semantic checks.
register allocation and stuff.
Yes, yes.
So
yeah.
there was, yeah. And I don't know, you already took out the records and that helped.
Yeah. So in terms of floats, though, in backend, is there any additional work because of that, or?
Well, they go into different registers.
Okay, that kind of stuff, bookkeeping kind of work.
Yeah. And then if you're going to allocate registers, you have to run the graph on both of them independently.
Yeah, that's correct. That's correct.
So that's so it's also more work.
Yeah.
So that's what I would pick.
Yeah. Right. In fact, we were thinking of adding few things, but it looks like maybe first we have to subtract and then only add, because there's not much room for adding things there. Especially interprocedural one is an important one. Without that, the compiler experience is not really complete.
Right.
You have to send values to be able to, put it on stack and all those kinds of things. So that is one component which we badly wanted to put it in the back end. Maybe we'll do this, what you're suggesting, that in the back end, get rid of floats and put that component instead. And hopefully...
Once you've done the floats, the integers, the floats is the same work. You just have to basically type it all out again.
Right.
So there's not necessarily additional learning there.
Yeah, yeah. No, I see the point. But you have to replicate and you have to maintain the, what you call it, do a lot of bookkeeping there in terms of the mixing the things and so on. So,
although you do there's some workaround. Okay, I'll admit I didn't do it yet. Coercing ints to floats. I think that doesn't have, you have to call special functions for that. Special MIPS functions for that.
Yeah. Yep. Type conversion. But those are a lot of engineering related stuff, I guess. If I were to pick again, I think sending the parameters and return values and all the stack management and AR management is probably more important than this, I think. Because without that, I think anybody may think that, hey, you have just done, you're not really done interprocedural, and any language definitely has to have that.
Right.
And the other thing that we didn't do is object-oriented, but that's also middle end, a lot of resolution there. The semantic analysis obviously gets a little hairy there in terms of inheritance, implementation, and all this. And that's another place where we wanted to give a little bit of exposure, because nowadays every language is object-oriented, and that inferencing and all is really important there. But I think between the two, maybe the first step maybe to put in interprocedural stuff.
Yeah. Well, the way you did the while loops in the homework, I thought that was good, because we didn't have to implement the whole thing. But we could just sort of show an example of how you would implement it. So you didn't.
Right. So just to show a sketch of the code generator and the modifications in terms of the, what information is to be sent around and all that. So yeah, it's definitely, the field is pretty fast, and this is just a starting point of everything. And on campus, we do a next level class here, which is getting into the issues that you were mentioning, like SSA and so on. It starts off from there and gets into advanced. So the middle end and things get really stressed in that class, because we really had to learn all these new optimizations, and for that we need a new IR. And we don't offer that online because it's almost impossible.
Yeah, you need to talk to each other.
Right, exactly. It needs a lot of interaction, and but some students have asked me in past for slides and all that, and I've shared those. So those who are interested, I will be happy to do it. But that's not the same as learning the class in the real live setting. So, and you can, if you're in Atlanta, you can come and sit anytime. I teach this semester, but otherwise, I guess we don't record it and we don't make it available. But that's another class, which is the next one in line of this. So,
yeah. Does that talk about debuggers? Because when I'm doing this now, I'm going like, wow, how did you get the debugger to work? But I don't know. It's like a whole nother.
yeah, so no, not much, but we talk about, so when you turn on optimizations, you typically turn off debugging sometimes because
Right.
they don't go well in hand because you get rid of some code, as CSE and all that optimizations remove the code. So you don't have a corresponding way to map it because you removed it. So no, we don't talk much about that, but we talk about the currency of values at certain points. If certain values get completely removed or subsumed by other values, then how do you reconstruct them? And there's a whole bunch of new stuff which comes up there. And so modern compilers have become so advanced that they allow you to reconstruct some values, noting the fact that, hey, I removed it, but it was essential for debugging. And they are able to recover it using some techniques like, we call it rematerialization. So we talk a little bit about those kinds of things, but we don't really embrace debugging as a topic because it's a whole another kind of a topic by itself. But it's very important to have that skill. And I hope you guys are using GDB or whatever. And in my advanced class, they have to use it because you can't get around those. You can't debug a large-scale software just through observation or printfs or whatever.
I have a lot of printfs.
Yeah, that's right. That is the standard, easier way. And there are nice GDB, especially offers a lot of features to step through your code and localize the errors and helps you at least figure out what is going wrong where, and then from there you can employ a standard way of printfs, or you can go through breakpoints and you can step and so on. That's really the style, but at least localization, it allows you to find out where the problem is. So,
All right. Yeah, the other thing you mentioned I thought was interesting was the auto-generating test cases, which I thought about if I had endless time. Because if you look at it, you've got 10 different kinds of statements and 10 kinds of variables, and if you could just somehow spit out a bunch of test cases that use all the different combinations, that would be handy.
Absolutely. And for example, some variables may not be declared, and so you have lots of program generators for these test cases, and some of them may not declare certain variables. So you would then expect the semantic analyzer to give you that kind of error and so on. So then there will be some programs which are sound, which make it through all the way through the semantic analysis into the backend, and then it stresses the code generator. And maybe some of them are geared towards really checking if optimizations are messing up with something else. So you have a nice control over what you can do in terms of suppressing some things from a sound program and then making it more and more complex for the later parts of the compiler to get exercised. And in GCC and all, there were bugs. Intrinsic libraries, how they are handled, and intrinsic variables they are handled. Some macro expansions were not being dealt with properly with intrinsics. And you can imagine that I think it won't affect most of the users, but it will affect a very advanced user. And it will, especially if you're relying on compiler, and if it's not detected, then it's going to lead to a lot of problems.
Yeah, really. So.
So if you are in Atlanta area, you are welcome. I don't know if you are or not, or if you're visiting anytime. I always encourage students to drop by and meet some on-campus students, hang out, do a few things, and meet professors. One thing I see some students coming for graduation, they send us a note, and we would love to meet anybody who can, setting up a time. So
we'll see. I was there. I'm actually in Seattle, so but I was actually there a year or so ago. I went to Grace Hopper and walked by and got my Buzz card.
oh, nice. So maybe it's time to visit sometime, and the area is really beautiful during summer.
Yeah.
We have a beautiful campus. I don't know if you had been to our campus, but we have a very nice campus, although it is an urban campus because Atlanta is a big city. But it's nice during summertime, and we are relatively free because we are not teaching our online or on-campus classes. So
yeah. So well, thanks today. I wish I could come to more of these, but I have that day job, so it's hard.
I know, I understand, and so that's why I also thought of putting the office hours sometime in the evening after everybody is done. But then Paul is joining us from Africa, so
there's no win. So
there's no win for yeah. Unfortunately, we are recording it, but it's always good to see somebody live like you now, and whenever you can, if you could join. Of course, we have probably 1 or 2 remaining now, but do let us know how we can help, and do stop by if you are coming this side.
Sure.
Okay, I guess, are there any other questions or any topics, guys, which we need to discuss? If not, we'll be done for today, and we'll see you next week, same time. And in the meantime, get all these test cases and other things ironed out, and get your compiler tested, and get ready for the exam, because we do have a final exam with all the topics, and review those, and try to do the problems similar to the homeworks. And we'll talk, if you have any questions about the final exam, if something is not clear topically, that's the theme of our next week's office hour.
Okay.
Great. Thank you, Paul. Thank you, Robin, for joining. And thanks, guys, and see you next week.
See you next week.
See you next week.
Bye.
Bye-bye.